Hello everyone, in this video we'll discuss about selection sort algorithm. Selection sort algorithm is used to arrange a list of elements in a particular order, ascending or descending. In selection sort, the first element in the list is selected and then it is compared repeatedly with all the remaining elements in the list. If any element is smaller than the selected element for ascending order, then both are swapped so that first position is filled with the smaller element in the sorted order. Next we select the element at the second position in the list and it is compared with all the remaining elements in the list. If any element is smaller than selected element, then both are swapped. This procedure is repeated until the entire list is sorted. This is a step-by-step procedure for a selection sort. Step 1 is select the first element of the list, that is element at the first position in the list. The second step is compare the selected element with all the other element in the list. And the third step is in every comparison, if any element is found smaller than the selected element for ascending order, then both are swapped. And they repeat the same procedure with element in the next position in the list till the entire list is sorted. Let's see the logic for selection sort. List is the name of the array and size is the total number of elements in the array, and I and j are loop counter variables, and temp is a temporary variable for swapping. The first for loop is for pass and the second for loop is for comparison. For I is equal to 0, I is equal to 0 and 0 is less than size of array is 7, condition is evaluated to be true. Then outer for loop for j is equal to I plus 1. I is 0, 0 plus 1, 1. And 1 is less than 7. Size of array is 7. Condition is evaluated to be true. Then check the condition. If list of I is greater than list of j, list is the name of the array. If list of I, element at I index 15 is greater than element at j index. J is 1, element at first index is 20. 15 is greater than 20. Condition is evaluated to be false. There is no swap. J plus j become 2. 2 is less than 7. Condition is evaluated to be true. Then check the if condition. If list of I is greater than list of j, element at 0 index is 15. 15 is greater than element at second index, list of j, element at second index, that is 10. 15 is greater than 10. Condition is evaluated to be true. Then interchange. Temp is equal to list of I. List of I is 15. 15 is copied into temp. Then list of I is 0. List of I is equal to list of j. List of j is 10. Then list of j is equal to temp. List of 2 is equal to temp. The value of temp is 15. Now after swapping, the output is 10, 20, 15, 30, 50, 18, 5 and 45. J plus j become 3. 3 is less than 7. Condition is evaluated to be true. If list of I is greater than list of j, now list of I is 10. 10 is greater than list of j. Element at third index is 30. 10 is greater than 30. Condition become false. J plus j become 4. Condition is evaluated to be true. Then check the if condition. If list of I is greater than list of j, element at I index is 10 is greater than list of j, element at j index is 50. 10 is greater than 50, condition become false. J plus plus j become, then check the if condition. If list of I is greater than list of j, element at I index is 10, 10 is greater than element at fifth index, that is 18. 10 is greater than 18, condition become false. J plus plus j becomes 6, 6 is less than 7, condition is evaluated to be true. Then check the if condition. If list of I is greater than list of j, now element at I index is 10, 10 is greater than 5, condition become true. Then interchange, copy the value at I index in temp variable. Now temp is equal to 10 and list of I is equal to list of j. List of 0 is equal to list of j. Element at j index is 5. List of 0 is equal to 5 and list of j is equal to 10. List of 6 is equal to 15. Then j plus plus j become 7. 7 is less than 7. Condition is evaluated to be true. Then if list of I is greater than list of j, list of I element at I index is 5. 5 is greater than 45. Condition become false. Then j plus plus j become 8. 8 is less than 7. Condition become false. Then control transfer to the out of loop. After the execution of pass 1, first element is sorted. Then I plus plus I become 1 and so on. Let's see the complete example of selection sort. Let's start with pass 1. Select the first position element in the list, compare it with all other elements in the list, and whatever we found a smaller element than the element at first position, then swap those two elements. First of all, compare 15 with 20. 15 is greater than 20, condition become false. No swap. Then compare 15 with 10. 15 is greater than 10, condition become true. Then interchange. Then after that, compare 10 with 30. 10 is greater than 30, condition become false. Then compare 10 with 50. 10 is greater than 50, condition become false. Then compare 10 with 18. 10 is greater than 18, condition become false. No swap. Then compare 10 with 5. 10 is greater than 5, condition become true. Then swap. Then after that, compare 5 with 45. 5 is greater than 45, condition become false. List after first pass 5, 20, 15, 30, 50, 18, 10 and 45. 5 is at its right position. In the second pass, select the second position element in the list, compare it with all other elements in the list, and whatever we found a smaller element than the element at first position, then swap those two elements. First of all, compare 20 with 15. 20 is greater than 15. Condition is evaluated to be true. Then interchange. Then compare 15 with 30. 15 is greater than 30. condition become false. No swap. Compare 15 with 50. 15 is greater than 50. Condition become false. No change. Then compare 15 with 18. 15 is greater than 18. Condition become false. No swap. Then compare 15 with 10. 15 is greater than 10. Condition become true. Then interchange. Then compare 10 with 45. 10 is greater than 45. Condition become false. No change. List after pass to 5, 10, 20, 30, 50, 18, 15 and 45. In pass 3, select the third position element in the list, compare it with all other element in the list, and whenever we found a smaller element than the element at first position, then swap those two elements. First of all, compare 20 with 30. 20 is greater than 30. Condition become false. No swap. Then compare 20 with 50. 20 is greater than 50. Condition become false. No swap. Then compare 20 with 18. 20 is greater than 18. Condition become true. Interchange. 20 with 18. Then compare 18 with 15. 18 is greater than 15. Condition become true. Again interchange. 18 with 15. Then compare 15 with 45. 15 is greater than 45. Condition become false. No swap. Then after pass 3, list become 5, 10, 15, 30, 50, 20, 18 and 45. In pass 4, select the fourth position element in the list. Compare it with all other element in the list, and whatever we found a smaller element than the element at first position, then swap those two elements. First of all, compare 30 with 50. 30 is greater than 50. Condition become false. No swap. Then compare 30 with 20. 30 is greater than 20. Condition become true. Then interchange 30 with 20. Then compare 20 with 18. 20 is greater than 18. Condition become true. Then interchange 20 with 18. Then compare 18 with 45. 18 is greater than 45. Condition become false. No change. No swap. List after pass 4, 5, 10, 15, 18, 50, 30, 20 and 45. Then in pass 5, select the fifth position element in the list. Compare it with all other element in the list, and whatever we found a smaller element than the element at first position, then swap those two elements. Now compare 50 with 30. 50 is greater than 30. Condition become true. Then interchange 50 with 30. Then compare 30 with 20. 30 is greater than 20. Condition become true. Then interchange 30 with 20. Then compare 20 with 45. 20 is greater than 45. Condition become false. No swap. List after fifth pass 5, 10, 15, 18, 20, 50, 30 and 45. In sixth pass, select the sixth position element in the list, compare it with all other element in the list, and whatever we found a smaller element than the element at first position, then swap those two elements. Now compare 50 with 30. 50 is greater than 30. Condition is evaluated to be true. Then swap 50 with 30. Then compare 30 with 45. 30 is greater than 45. Condition become false. No swap. List after 6 pass 5, 10, 15, 18, 20, 30, 50 and 45. In 7th pass, select the 7th position element in the list, compare it with all other element in the list, and whatever we found a smaller element, then the element at first position, then swap those two elements. Compare 50 with 45. 50 is greater than 45. Condition become true. Interchange 50 with 45. And finally, the list is sorted. Let's see the program for selection sort. Inside the main function, first of all, declare variables. Size is the variable for total number of elements in the array. I is the loop counter variable for outer loop, and j is the loop counter variable for inner loop. And temp is the temporary variable for swapping, and list is the name of the array, and 100 is the size of the array. First of all, input the size of the array. Then after that, input array elements. Then selection sort logic. The first for loop is for pass and the second for loop is for execute a pass. In second for loop, we have to compare element at I index with element at j index. If the element at I index is greater than the element at j index, then interchange, otherwise increase the value of j by 1 for next comparison, and so on. And finally, display the list after sorting with the help of for loop. Let's see the output. Enter the size of the array. Size of array is 5. Now enter 5 integers 3, 4, 5, 8 and 2. List after sorting is 2, 3, 4, 5, 8. Next is the complexity of selection sort algorithm. Best case, average case and worst case. The best case complexity of selection sort is big O of n square. Best case occur when the array is already sorted, where n is the number of integers in an array. And the average case complexity is also big O of n square. The average case arises when the elements of the array are in disordered or random order, without a clear ascending or descending pattern. Then the worst case. The worst case complexity of selection sort is also big O of n square. The worst case scenario arises when we need to sort an array in ascending order but the array is initially in descending order. The time complexity of selection sort remain constant regardless of the input array initial order. At each step, the algorithm identifies the minimum element and places it in its correct position. However, the minimum element cannot be determined until the entire array is traversed. The number of iteration in first pass is n minus 1. Number of iteration in second pass is n minus 2. And number of iteration in third pass is n minus 3. And the number of iteration in last pass is 1. We can say in pass 1 number of comparisons are n minus 1, in pass 2 number of comparisons are n minus 2, in pass 3 number of comparisons are n minus 3, and in last pass number of comparisons are 1. The number of comparisons in selection sort can be calculated as a sum of n minus 1 plus n minus 2 plus n minus 3 plus up to 1, which is approximately equal to n of n minus 1 divided by 2. That's why the result in time complexity of selection sort is big O of n square. The space complexity of selection sort is big O of 1, as no extra space is required for the selection sort algorithm. That's why selection sort algorithm is not a stable sorting algorithm. This is all about selection sort.